Okay, hello everybody. I think we're live. I think we've got everybody here. So thank you all for joining. We'll give it a minute or two just to let a couple more people connect and get set down at their desk and all that. But then we'll get started right away. We've got a pretty sweet presentation here with Dylan and Paige. I'll introduce both of them in a second. Wow, I see a lot of people coming in. Awesome, awesome, nice. So maybe while people come in, I will slowly introduce Dylan Paige. So, hey everybody, my name is Laurent. I'm looking at the list. I think I've sent emails to most of the people on this list as part of our customer support at some point here. So nice to see you all. And say hi in the chat if you want. Say hi, your role and maybe where you're coming in from, where you're logging in from. It's always fun to see where everybody is coming in. And so just really quickly, like I said, my name is Laurent. I'm an engineer here at ClearCalcs. We are partnering with Forta and Helix today as part of our Lunch and Learn lunch hour. We're here to help you learn about new products, new ways that you can get your work done. And so with Forta and Helix, we'll be talking about some new materials and alternative materials you can use in concrete construction. And so, just to introduce briefly, Dylan and Paige are both working with Forta and Helix. I'm going to get confused here, but Helix is a part of Forta. And so they will be presenting on this today. They can introduce themselves better than I can, to be honest, but give them a warm welcome. And I will give it away. So, Dylan, Paige, welcome and take it away.
Hi everybody. So I'm Dylan. I'm on the Helix side of things. I am based out of Florida currently, but born and raised in Texas. So a little bit of a change. I got my degrees in engineering from Texas, and that's where I did the bulk of my design work before transitioning into more of a sales education role. And I've been with Helix, which is now a part of Forta, for a little over a year. So excited to be here presenting for you today.
Hi, everyone. My name is Paige. I am a newer employee at Forta. I've started a couple months ago, and I joined our engineering team to support Dylan and another colleague. His name is TJ. So Dylan is representing mostly Helix Steel and the steel fiber product, and I am representing Forta and their synthetic fiber product. But my background was civil and environmental engineering from University of Pittsburgh. So hail to Pitt for anybody out there that has also graduated from that school. And over the last couple of years, I've done some design work on the land development side of things, and then actually got a little bit more into the stormwater management design side. But now we are all focused on concrete.
Yay, okay. So right off the bat, we started going out of order, but that's totally fine. I'm just going to skip the...
Oh, yes. Here are pictures. I guess something to note is that with the full acquisition that happened last year, Forta acquired Helix Steel, and with Helix Steel having a ton of familiarity in the industry, we decided to keep that branding name. And so that's why you'll still see things specific for Helix Steel, but keep in mind that everything now falls under that Forta umbrella. So we're able to bring both a synthetic and steel solution to the table. So we were able to get these two things together, and now we are a very solutions-based engineering group, and we're able to provide more designs than just one product. So that merge was really important for our group. And the headquarters of Forta is in Grove City, Pennsylvania. And then Helix Steel still has its engineering office in Ann Arbor, and then their manufacturing facility in Grand Rapids.
And the presentation that we're doing today is alternative materials in concrete construction. So we're hoping to give you a broad overview of how to incorporate alternative materials into projects, and hopefully break any stigma that it's super challenging or not worth a look at. Sorry, can I go to your slide? Go ahead.
Oh, no, Make sure that this slide is reminding everyone that we're able to give you a credit for sitting in today's presentation. So make sure that you get with us after this event. Maybe at the end, we'll give you that moment to jot down our emails so that we know exactly who is going to want that.
It is an RCEP accredited presentation, so it's good for one PDH or CEU. So we are happy to send it out. And yeah, just what I touched on earlier.
Yeah, hopefully by today, everyone is going to realize that, yes, with concrete being an older field, a lot of people are used to doing designs with traditional reinforcements, but we really want to help identify where we can be with fibers and help you in that space. We can also discuss how we can implement this into any projects that you're working on. We'll run through some of our ISO reports, and then it will explain how we can fall into some of these specifications. And then towards the end of the presentation, we'll definitely kick off some project examples so that you guys can see what has been done in real life.
Perfect. Okay, is everybody ready for the technical discussion? Because we are just going to jump right in.
And yeah, to start off the technical slides, there are a couple things that allow for fibers to perform better in concrete. And the key is to look for the deformation of the fiber itself. So both the synthetic and steel options are twisted. The synthetic is crimped as well. And the steel has a rectangular cross-sectional area. So all of these features and deformations allow us to lock into the concrete better. So similar to a screw in a piece of wood compared to a nail, it's going to just really help hold things better. Fibers definitely come in a variety of sizes. We can say very clearly that not all fibers are created the same. There's macrofibers, which I'm sure everyone is familiar with. We'll get into our the micro, the macro, and then eventually the steel fibers. So these three main categories. First, talking a little bit about these micros. This is a residential fiber. It's typically dosed at 1 pound, and it's just used for plastic shrinkage to the surface of the concrete. So these can come in a variety of sizes, all the way down to 1/4 of an inch up to 3/4 of an inch. And these are things that you would see a lot in flat work. But then for the next slide, as we get into more commercial projects and that type of work, we have this fibrillated network fiber option, and it definitely will anchor better into the concrete, similar to a fishnet. As it pulls apart, we could see that these networks hold the concrete together. This is what can be used to replace some light duty mesh. Super light duty, we would dose this around 1.5 pounds, and there are two standard lengths, 3/4 of an inch up to 1.5 inches. And essentially, we can replace very light duty wire mesh, strictly there for maybe TNS control. And if anybody happens to have questions on where this would best be used, feel free to write it down. But where we definitely want to talk a little bit more about, and things get a bit more exciting and we can set ourselves apart better with our macrosynthetic option. So this is our bread and butter, known as a structural fiber. This can be used to replace essentially all mesh, including heavier duty mesh, and for that being temperature and shrinkage. And the macro can also replace lighter duty rebar as well. So of course, that will depend on the exact bar spacing and sizing, but whether it's a single layer replacement or a double layer, we're going to be dosing these anywhere from 3 pounds to 7.5 pounds on slab on grade, pavements, slab on metal deck. What is important to note is that when you are able to replace some of these mesh and bar options, you are going to be, paying less for the material costs. But where things really start to pay off is the fact that when you are on site, you do not have to lay down that mesh or bar anymore. This fiber would be mixed in at the plant and finished at that point. And honestly, the time and labor is where these types of fibers really start to shine.
Not only do you not have to tear out that fiber, or that mesh, you also don't have to buy the SBU for the chairs. So it's a benefit all around. So now we're into the steel options. And so the product that we offer is a twisted steel micro reinforcement, which is a little bit different than some of the other steel fibers that you may see on the market. Ours is a high strength steel, so on average it pulls around 246 KSI. It is zinc coated, so corrosion resistant. This fiber is an inch long and 0.02 inches in diameter. So the name of it gets it from its geometry. So 25 millimeters and then 0.5 millimeters in diameter. It does have a rectangular cross section, and it has at least one full 360-degree twist per fiber. All of the steel products that we do is made in Michigan, so it is an American product, which can be beneficial for certain types of work. So how do we get products like these incorporated into projects? On the steel side, if you look at it in the light of the hierarchy of the building code, which is ever since we pulled from Australia, we are offering more of a performance-based solution. So we are complying with the objectives and the functional statements of the code, but we're doing it with performance-based data. So the way that we do it is with our evaluation reports. We have two of them. We have our ATMO report and our ICC report. They are a little bit different in nature and do cover different applications, and we'll go through those a little bit so you have an understanding of what those are. But they do comply with Section 110 of ACI 318, which is the consideration of alternative construction materials, design systems, and construction methods. Okay, so the first report that we'll talk about is our ICC report. It is a little bit newer, and the information in this report is based on the fiber actually increasing the modulus of rupture of the concrete that it's mixed into. So this is the report that we like to use when we're looking at plain concrete applications, slab on grade, or footings on grade. So any kind of application like that, this is a report that we'll typically design those dosages with. So these are a few of the beam tests that we've used to determine the values listed in the report. And what you can see is the dosage of the twisted steel micro rebar increases, so does the modulus of rupture of the concrete. So typically when you're doing a plain concrete design, you'll use about 5 times the square of the compressive strength of the concrete. And when you're using a dosage of a twisted steel micro rebar or a steel fiber in this case, that can increase to anywhere between 9 and 12 times the square of the compressive strength. So you do get a significant increase in capacity. And then the second evaluation report that we have, which is also the original one that we pursued, is the IATMO report, and it focuses on a direct tension approach. So we actually do, a test, and the specimen looks sort of like a dog bone, and you put 2 anchors in each end and then pull it to see what the maximum load is you can apply to a certain a specimen with whichever dosage of fiber you're testing. And the whole behavior of this test goes back to the geometry of the fiber. So because it's twisted, it behaves more like screw instead of a nail. So you're going to need substantial force up front to get it to start untwisting versus just having it slip out of the concrete like a nail would. And so if you look at this video on the right, you can see that we have anchors attached to a fiber. And if you watch that flag, you can watch it untwist in real time as load is applied. And this graph on the left shows the different behavior between a twisted steel micro rebar fiber and then a hooked fiber and a straight fiber. So you do need significantly more force to pull a twisted fiber out of a concrete specimen than you do a hooked or a straight fiber. Oh, who's that? What is happening here? Are we going crazy? Oh. Bear with me. It's something about this slide 19. Okay, can we see it? This is the dog bone test. Okay, so this is where we take certain dosages of the fiber and we mix it into the specimen you see on the left, and then those two anchors, the one in the top and the one in the bottom, pull to separate that specimen and see when it cracks. And as the number of fibers per square inch increases, so does that force required to crack the concrete specimen. That was a lot of work to get that slide through, not much. What is going on? All right, let's try. Okay, can you see it?
Perfect.
Okay.
Yes. So we'll work through this quickly just because we don't want to lose it. But now for our synthetic product, we do run a beam test to see where it cracks, essentially unload it and then reload it to tell us what that stress is across that cracked area. So this is a way that we're able to provide a more durable based design from a slab pavement perspective. And it's providing load transfer across a crack or a saw cut, same concept. And this is why we're able to look at this to have light cracking, or when we're looking at racking on a slab, moving fork truck traffic. It's just another way to design from looking at it from a post-crack perspective. And what we're able to get from this is the residual strength post-crack from the addition of fibers. And so essentially we're testing that residual strength and how we're able to get our numbers for this.
Oh my goodness. Okay. I do it every time.
And we do have an evaluation report for this product as well. And this one is essentially saying that we're able to increase the toughness. We're going to get that better ductility. When we have a 3D matrix of fibers of a homogeneous mix, you're definitely going to have that improved ductility. And then abrasion, that could go along with pavements and slabs. And then some of those last bullet points are going to help with any sort of exterior concrete. And it will definitely be an improvement from those two levels.
Oh, it was funny one time, but it's not funny anymore.
So just a couple things that are important to note on this slide. We like to keep the compressive strength the same. So as long as the design and the mix and the engineering behind it is considered without fibers, then that is going to be how we like to approach things. Sure, we might get some increase, but we just want everyone to know that it's not going to impact the compressive strength. Also, in terms of the air content, we want to make sure that the concrete is coming out just as well, especially if you're designing a building. So if you guys would be worried about any sort of effects with this, then all of our fibers will not affect on the air content as well.
Oh, there you go.
So it is important to speak to a few of the contractor benefits because as you engineers may talk with owners, any of the other clients, if they ask you why fibers matter, just a couple of points why they are important and can bring benefit to a project. First thing, increased job site safety. There is that lower chance of tripping over hazards such as wire mesh or bar. And then you will definitely see a decreased hours on project. So whenever it comes to the cost of fibers, you know, it might be a little bit cheaper or a one-to-one material cost for the steel. But where the real savings start is for those guys to lay that mesh or tie the bar, putting things up on stool, etc. We are taking out a huge aspect of the project where the pricing lays. So we just want to make sure that the site is prepped and it's as easy to lay the concrete as just laying it out and then it gets finished. So no extra man hours there. But whether the workability is a factor or question, there's real no difference in workability. We will have guys on site to help with any questions that might come up while they're putting the mix together.
And real quick, we have a question. Is there any data about the corrosion resistance of steel fibers in harsh environment? Is there a standard test for it? And while we do not have a standard test for it, we do have many case studies about steel fibers being used in brackish environments and saltwater environments, and also in concrete where there's constant heavy machinery and scraping of the slab. So if that's something you're interested in, we can definitely provide that information, and we do have examples of that listed on our website.
And to make sure that everyone fully knows of what all our company is capable of in terms of giving you solutions, we have a whole engineering team that we're able to provide those calculation submittals, and we have the ability to stamp in all 50 states. So if we need to treat something as a delegated design, not saying that we're taking over as the engineering record, but we can easily do that design. And please send us any sort of projects that you want us to look at for straight up conversions where we take the original mesh, rebar, and then just give fiber dosage for it. Or we can look at things from a load-based design.
And when we do that, so if we are looking at a project from the back end, so say it's something that a contractor has sent in and they want to do a conversion on it, we'll put together a full calculation package for the contractor to then submit to the EOR, and we'll provide any assistance needed with building official questions or anything like that. So we do want to make sure that it's a smooth process. And then if we do it in reverse, so if we're assisting the engineer on a design, we're happy to provide those same calculations and help answer any questions that you may have on the front end. So we don't expect anyone to be doing these designs on their own. That's what our engineering teams are here to help with. We know everyone's super busy and nobody has that kind of time. So we do want to make sure everybody knows that those are services that we do offer. Okay, some project examples. So these first ones that we're going to go over are going to be using the steel products, and then we'll hit on some of the synthetic fiber examples. So let's start. Okay, so this project was close to our hearts in Michigan. So it's in Detroit, and this was on a project, a skyscraper. It was the first skyscraper, I believe, since 1979. It's been permitted in downtown Detroit. So we were able to go in on all of the elevator decks and replace the wire mesh that was originally specified in those. And so they were able to pump the concrete with the steel fiber, no problem. That is a question that is sometimes asked. But the fiber is not much bigger than the largest aggregate. So if you can pump the aggregate, you can pump the fiber. Another cool application that we got to do were the piles for the Ferris wheel in Seattle. And I actually got to go on it and ride it before I ever worked for the company, and I had no idea, but it's cool looking back. But we were able to go in and replace, these are steel encased piles also, I would like to add, so nobody gets super excited, but we were able to go in and replace the 8 number 6 bars and the number 3 hoops at 12 inches on center entirely. And all that is left is 1 number 6 bar down the center of each pile, and then the steel fiber. So it saved them quite a bit of installation there. And then a type of project that we do, I would say it's probably our bread and butter, but large scale distribution and warehousing. So heavy industrial slabs. This is one that we did in North Carolina. This slab originally had 2 layers of number 5 bar, so 1 top, 1 bottom, and it was at 12 inches on center each way. And we were able to go in and fully remove all of that bar so that all they had to do was mix fiber in and go. So it's approximately like for every 10,000 square feet of slab that you're doing, you'll save a day by switching to a fiber option. So if it's a tight schedule, it really can be beneficial. And then this was a large project in Ohio. It was about 3 million square feet of slab, so quite a bit. And there were 3 different thicknesses, and we were able to work with the engineer on the front end to determine 3 different fiber dosages so that they didn't have to mess with the rebar. And something that I like to add is when we go in and look at projects, we try to not ruffle feathers. So we want to keep it as similar to the original plans as possible. So if you think like control joints, for example, we aren't going to change them unless we really have to. And so, for example, on this project, we were able to keep everything that they had and just give them our dosage. So we try to make it as streamlined as possible. But at the same time, we also can do things if we have enough information. So if we have the geotech data and the loads, the full loads that are going to be on a slab, we can provide extended joint systems. So we can go, I think the farthest that we've gone is 130 feet on center. So we can provide some more Cadillac options if that's something that's important to the project. But you know, it is a versatile construction material. All right, macrosynthetic, you ready?
Yeah. All right, so for this hangar project, I like showing this example because, as it was mentioned, macrosynthetics can be used to replace a light duty bar at higher spacing. So with this being number 4 bars at 18-inch spacing in a 1-foot thick slab, that just made for a really good option for a macrosynthetic. And so this was originally spec'd in with 2 layers of number 4 bar. And so ultimately, this made for an easier placement for the contractor, saved the owner money whenever it came to material cost and man hours, since they didn't have to tie 2 layers of number 4s. So some of those benefits would probably be consistent across a lot of these project examples that we're seeing. And then for this next one, just another hanger option showing how we can put an epoxy on top as well. So just keep in mind that we can do up to 7.5 pounds of dosage with these microfibers. They're dosed anywhere between 3 pounds and 7.5. Anything over that amount might get hard to finish. So we would consider a steel fiber at that point, and Dylan might take over the project. So typically for workability and constructability, we will recommend the steel fiber if we're getting above that 7.5 pound for dosage on the synthetic side. This is a good example to show how we can do a good polishing as well. So this was an art museum. There was a deep grinded polish at 7.5 dosage rate. So with that high dosage rate, visually, you're still going to have something that can turn out very clean. For this healthcare facility, It touches on both the 3-pound and 4-pound dosages. So the 3-pound was to replace the mesh in the slab. And because it was slab on metal deck, became a 4-pound dosage rate. And something that's really convenient for the contractor is they don't have to bring that wire mesh into that enclosed building, and it makes it a lot easier. You're not having to pay for guys or equipment to bring that up onto that metal deck. So lots of cost savings for material and man hours. This was a good example just because it made for a much easier pour for them. If they had that number 5 bar at 10-inch on center, they might not have been able to pour out as quickly, and they wouldn't have been able to use that laser screed as efficiently. So this pavement was put down a lot quicker. And so I think between this example and the next one, it was in the agricultural industry. And so then for this last example, it was a little bit more unique of an irrigation channel, but again, big time savings. We're getting more longevity and more durability in this concrete for these channels as water and debris flow through. And so all of these benefits that I've previously walked through, they're going to apply. And at the end of the day, they were able to get a much more durable basin by implementing with fibers. But hopefully these examples gave you guys a little bit better of an idea of how they can actually apply to the real world examples. So at this point, please jot down our emails, our phone numbers. Make sure to reach out to us for any questions that you guys have. Our turnaround time is really nice and quick for something where if you send us a project and you're looking to see what that conversion might look like, give us 2 days, maybe 3 days, and we'll get something back to you.
Yay, and it looks like we have another good question. Is the product added on site? And we can do it either way, but we do prefer for it to be added at the batch plant. We have instructions and guidelines for both wet batch and dry batch. But we typically like to see it done that way because it gives a more even addition of the fiber versus sometimes on site it can be added hastily, and if it goes in clumps, it's going to stay clumps. So we want to avoid that at all costs. So if it's done properly, it can be done on site or at the ready mixer, but we prefer with the ready mixer.
I do see a question in the chat. Can this be used in single family residence applications? And yes, Dylan can probably elaborate on this a little bit more as we utilize this in ICF designs.
Yes. So let me flip over. Oh boy. Okay. So we do. That is one of the benefits of using a fiber versus some of the other custom reinforcement options out there, because it can be scaled down to a single family home, and then up to anything as large as millions of square feet of industrial plants. And so for homes, a lot of times we'll do ICF walls, we do slabs and then the foundations, driveways. We can't do CMU because our evaluation reports don't cover that application. But as far as ICF, it is very commonly used and does save the contractors a lot of time, especially with that horizontal bar that seems to be super troublesome to put in. It can totally remove that. And that does bring up another good point that I didn't mention, but with that second evaluation report that we have, the IATMA report, because it's using a direct tension methodology, it does allow us to go in and replace not only temperature and shrinkage reinforcement, but flexural and shear reinforcement. So we get into some heavier designs, and we can even go into some higher seismic design categories as well. But most of the time that will end up in a hybrid design, which will be a fiber and rebar. It'll usually be a more reasonable amount of rebar, but you will have both. What else do we have? I'm scrolling.
We've got a question from Keith here, who I think when you were showing the example was asking about rebar at the cold joints.
Oh, so yes, ad bar, we do still require anything like reentrant corners, dowels, bar at the cold joint. That stuff will all remain as it would with a typical rebar design. The fiber is just going in and replacing the main reinforcement or the field reinforcement.
Awesome. And we had another one about how we can reduce permeability.
So the way that the fiber works is it's designed to transfer load from the supply more efficiently throughout the specimen. So those cracks that occur are going to be smaller than they would with the traditional rebar that allows for a little bit wider cracks. And so that's where we see some reduction in permeability.
Yeah, along those same lines, because we're improving the durability of the slabs, we're trying to prevent those wide cracks from happening. So if we maintain that tighter matrix with the fibers holding everything together, it's, I guess, indirectly contributing to lower permeability and just better protection of all of that reinforcement.
And we've got another question here from William. Are there any issues with concrete suppliers adding the product at the plant? Is the product readily stocked at plants?
So I believe that the macro and then the steel fiber operate a little bit differently in that, whereas I'll speak for the steel first. We don't stock at plants. We're more ordered on a project basis. So when we work with a contractor or a specific project, we'll coordinate with them to see which plant they want to use and then ship directly to that plant and send someone down there to walk them through dosing instructions so that there aren't any problems that we can avoid. And then Paige, it's different on the macro side if they stock or if they send it per project.
There are some ready mixer plants that will keep the fibers on site just for the convenience. But at that point, those are the folks that we have good relationships with. They know exactly when to utilize certain things. But I think that based off of our general recommendations, we want those fibers to be added at those ready mixers and not at the site. We can do it on site. We're just going to definitely want to have some representatives on site to make sure that things are as smooth as possible and everything looks good.
And as far as special instructions for the plants, it depends on what type of plants they're running, but we do provide like a full breakdown of the best practice for dosing so that it goes in smooth and unclumped, whether that be adding it in the front end with a bit of the headwater so that it's constantly spinning, and then they go in and add the remainder of the material, or if they add everything and then post-load it. So there are different options depending on what type of plant it is. And then as far as deep grinding and polishing to remove the hairs, what we like to say about finishing is that it is very critical to let the concrete sit long enough so that the paste layer develops on the top, so that when they go in and they float it for the last time, any of those fibers that are wanting to stick up, it'll go in and smooth it back down, so that you don't have those hairs sticking up. It'll all come down to best practices when finishing to make sure that you don't have a hairy slab, because we know nobody wants that.
Awesome. I see. I think that addresses all the questions I saw. Last chance if anybody's got any other questions. Otherwise, I'm going to say thank you, Paige and Dylan, and thank you everybody who's joined us today. this is something that we like doing at ClearCalcs, is to share knowledge and to invite people who are smarter than us and can tell you more about these new products coming out. And so please reach out to Paige and Dylan if you've got any question about fiber reinforced concrete, about Forta, about Helix Steel. They're here to help. Or you can also reach out, us, hello@clearcalcs.com. We're here to help with anything related to ClearCalcs, or if you want to pass some questions along to Dylan and Paige as well. I think you're going to get a survey when you leave this. Please fill it out. It's how we can make this better for you. It's how we can make better webinars in the future for you. If you've got questions again or comments that you want to send down to Dylan and Paige, we'll make sure that they get that as well. Otherwise, I'm going to wish everybody a great day, a great morning, great afternoon, depending where you're at. Thank you so much, and see you next time. We've got some more webinars coming. Stay tuned.
Thank you so much.
Thanks, guys.
Bye-bye.